Imagine a world where towering giants once roamed freely, but a cataclysmic event erased them from existence in the blink of an eye. The Earth's surface was transformed into a wasteland, firestorms raged across the land, and a suffocating darkness descended for years. The very air we breathe, the ground beneath our feet, and even the oceans seemed to tremble in response to the aftermath of an event that forever altered life on Earth. But what came after the dinosaurs, and how did this massive extinction event give birth to a new world? The asteroid hit Earth 66 million years ago, which, in a series of awful events, changed the face of the planet in a very short time. The asteroid was 10 to 15 kilometers or 6.2 to 9.3 miles wide, and it was moving about 40,000 miles per hour, or 64,000 kilometers an hour, when it hit the Yucatan Peninsula with the power of over 10 billion atomic bombs. The impact sent temperatures soaring to thousands of degrees, instantly vaporizing nearby rock and carving out a massive crater, now called the Chicxulub crater. The impact left a massive scar on Earth's surface, an enormous crater approximately 180 kilometers or 112 miles in diameter, nearly 20 kilometers or 12.4 miles deep. Hundreds of billions of tons of scorched rock, dust, and vaporized material were blasted into the sky by the colossal explosion. As the debris re-entered the atmosphere, it generated searing heat, igniting wildfires across thousands of miles of forests and grasslands. These raging firestorms filled the skies with ash and soot within hours, plunging the planet into what seemed like a global catastrophe. Shockwaves quickly spread out and caused some of the largest earthquakes ever to shake the Earth. The tremors triggered huge landslides, especially in mountains, and set volcanoes to erupt around the world. Tsunamis more than 100 meters, or 328 feet high, rushed inland along coasts, destroying ecosystems, knocking down forests, and flooding areas as large as entire states. The waves traveled thousands of kilometers, with evidence of their destruction in New Zealand and Antarctica. It caused much devastation in the atmosphere. The impact hurled roughly 15 trillion tons of soot, dust, and sulfur particles into the upper atmosphere. This cloud blanketed the Earth, blocking sunlight. This caused an extended period of the nuclear winter. This resulted in global temperatures dropping by up to 25 degrees C, or 77 degrees Fahrenheit, leading to an extended cold weather condition for quite some years. Photosynthesis nearly came to a halt, and plant life died. Herbivores, which relied on plants, soon starved, followed by the carnivores that fed on them. Acid rain is a result of chemicals in the air that mix with water. This destructive rain poisoned lakes and rivers, damaged soil, and affected water and land animals. Marine life suffered massive losses as plankton populations, tiny sea creatures, the base of the ocean food web, fell apart in the cold, dark waters. These quick effects of the asteroid hit formed the most important mass extinctions in Earth's history by killing about 75% of all species, a change that will continue changing life on Earth permanently. The immediate aftermath. The result of the asteroid hitting Earth made it look very different, putting it into a long time of confusion and emptiness. Fires started by the heat from the debris that flew back into the atmosphere after the impact spread across countries. These fires burned down whole forests, turning green areas into burnt land. Rivers and lakes full of life became still and poisonous, blocked with ash and debris from the major destruction. The dirt and sulfur in the sky plunged the Earth into an eerie, endless twilight. They blocked sunlight for up to 15 years and threw the world into darkness. A very large, abrupt drop in temperature created this strong cooling event. Ice spread to the poles, but even the tropical conditions of the Cretaceous began to turn into unbearable conditions, with frost, and cold spreading over them. This impact winter presented conditions that were nothing like life had ever seen before in facing the species. Survival relied on being strong and adapting. Small mammals, which people often ignored when dinosaurs were around, were very good at this. Their digging habits protected them from fires and severe cold, and their ability to eat many types of food helped them find seeds, insects, and dead animals. Birds, which are quick and can move easily, used their flying skills to find the little food that was left. Crocodiles survived these difficult times as they have slow body processes and could survive without eating for a long time. After the destruction, signs of recovery started to appear slowly. Strong plants like ferns, which grow well in poor soils and grow fast, were some of the first to return to the damaged land. Their return marked the start of nature taking back a burned and frozen Earth. Even though life continues in small areas, Earth has changed a lot. The survivors, much smaller in importance than the great dinosaurs, would help create the planet's future recovery, leading to a new time of evolution and variety in nature. The dawn of the Cenozoic Era. The Cenozoic Era began 65 million years ago. This period was important in Earth's history after the impact of the big asteroid. When the non-bird dinosaurs became extinct, the balance they had for more than 160 million years was lost. This allowed new life to grow and thrive. This time is often called the Age of Mammals, but its story goes much further than mammals. It includes the rise of amazing animals, different ecosystems, and new types of evolution. The first phase of the Cenozoic, the Paleocene Epoch, was a time of recovery and rebirth. Damaged and empty landscapes gave way to lush, tropical forests. It was a time and place perfect for revolutionary changes. The mammals, small, hard-to-notice forms, had survived the aftermath of the asteroid and started diversifying very fast, filling up empty spots that had been left by the dinosaurs. Often, these early mammals were small, rodent-like creatures, yet in them lay the seeds of future giants and predators. Now no longer competing with the powerful pterosaurs, birds have evolved into new forms. Some become small and agile again, adapting to dense forests, while others become land hunters, like the smaller meat-eating dinosaurs. These bird adaptations were like the new inventions on land and in water. The oceans, damaged by the extinction event, began to heal slowly over time. Marine ecosystems calmed down as old fish species adapted to suit their new environment, and early whales gradually evolved into exclusively aquatic mammals. Among the most amazing feats of the Paleocene, perhaps the most remarkable achievement is the rise of the Titanoboa, the biggest serpent known to have ever lived. Fossils in South America show that the predator grew up to 42 to 50 feet, or 12.8 to 15.2 meters long, and weighed over 2,500 pounds, 1,334 kilograms. This great snake thrived in the swamps and rivers of a warm, wet Earth, with its huge variety of life at the time. It hunted big fish and crocodiles, taking control of its environment with quick movements and strength. Its huge size was due to the warmth of the Paleocene, which helped cold-blooded reptiles grow very large. Fossils of Titanoboa not only show how gigantic it was, but also give some idea of the warm, tropical conditions at the time. Another dominant predator came to the fore in South America's grasslands and forests, the forest rockets, or terrorbirds. These flightless birds, up to 10 feet or 3 meters tall, were the top predators in their isolated environment. South America's separation during this time kept outside animals away, allowing creatures like the terrorbirds to dominate. These birds had powerful legs that allowed them to run fast and sharp beaks that were well suited to crush their food. They were good hunters. They hunted small mammals and other animals entering their territory, keeping them at the top of the food chain. Fossil evidence proves that they did well for millions of years, but joining South America with other continents again brought in the competition of mammal predators. Terrorbirds roamed the southern continent's grasslands, while Entelodon lived on the shores of Eurasia, now called the Terminator pig. Although Entelodon bears this name, it was closer to hippos and whales than the pig of our day. Reaching in height like a bison, it weighed over 1,000 pounds or 453 kilograms and was no gentle giant since it hunted and scavenged for food. Its large paws with sharp teeth could easily break bones. This would enable it to eat dead animals or defeat smaller creatures. Fossil evidence shows many bite marks on Entelodon bones. This suggests that animals often fought each other, probably over food or land. Entelodon could adapt and was aggressive, which helped it survive for millions of years. However, as the climate changed and ecosystems grew, more specialized predators started to outcompete it. In the coastal areas of Asia, the mysterious Andrewsarchus appeared as one of the biggest land meat-eating animals of its time, mainly recognized from a huge skull over 3 feet long. Andrewsarchus probably looked like a giant wolf or hyena with very strong jaws. Fossil evidence proves it lived very well in coastal areas, hunting smaller mammals and feeding on dead marine animals. Its size and strength made it the largest predator in its food chain. Though many facts about Andrewsarchus remain unknown due to few fossils, it does prove the changes that occurred in the process of evolution during the Cenozoic Era. As these predators became top animals on land, a new leadership also emerged in the waters. Old fish species evolved and grew, and an early ancestor of whales came into existence. Each ecological system, from warm rainforests to ocean coasts, demonstrated how life is strong and used the opportunities that emerged during the aftermath of the catastrophe caused by the asteroid's destruction. Mammals and birds were the organisms that showed great adaptability. They changed quickly to exploit these new environments and ecological roles. The beginning of the Cenozoic period was a period of great change, reshaping life on Earth and leading to many species. With dinosaurs disappearing, new animals emerged, taking over the planet's ecosystems, showing fantastic changes that helped them survive, and filling the spaces emptied by their former rulers. The Titanoboa lived in swamps, and the terrorbirds were top predators. The strange Andrewsarchus and the meat and plant-eating Entelodon also existed. This time changed the world a lot. As land ecosystems changed, the oceans also saw the growth of amazing sea predators. The biggest were Megalodon and Leviathan melvillei, which made the seas like huge battlefields. Megalodon was a huge shark that had been swimming in the oceans during the Miocene and Pliocene periods. It was the sea's top predator. Megalodon could grow longer than 60 feet or 18.2 meters and had a strong bite force of 40,000 pounds per square inch, which makes it much larger than the great white sharks nowadays. Its sharp teeth, some longer than 7 inches, were designed for cutting through the flesh of big animals. It's pretty evident from the fossilized whale bones that had distinct bites from the Megalodon how powerful the beast was in hunting. It mainly preyed upon enormous sea creatures like baleen whales and dolphins, striking hard and then swallowing its prey as an attack by surprise. The life of Megalodon had some very interesting details about how it lived and survived. Young sharks probably grew up in safe coastal areas with many small fish and marine reptiles. The place offered a lot of food and protection from big predators. When they matured, they swam further into deeper waters, hunting in areas where warm, shallow seas had a lot of prey. Megalodon survived on top for millions of years, but environmental changes overwhelmed it during the Pliocene. Ocean temperatures were cooled by the start of the Ice Age, causing a disruption to the ecosystem and large prey that the megalodon fed upon. About 3 million years ago, this giant predator was extinct, leaving only its world-famous teeth as evidence of its reign. Other giants of the Miocene seas, along with Megalodon, shared space within the world's oceans, including a giant whale, Leviathan Melville, named after the orphan of Moby Dick, Herman Melville, had teeth the size and strength as the Megalodon's. Its length was reportedly up to 60 feet. Its huge cone-shaped teeth ranged from over an inch to over a foot, making these the largest of any recorded predator. These were meant to capture and pull apart huge prey, such as other whales. Therefore, Leviathan must have been an apex predator in its sea environment. Leviathan was different from modern sperm whales, mainly eating squid in deep waters. Instead, it hunted marine mammals that lived near the surface. It probably ate baleen whales, which were common during the Miocene, and its strong jaws could easily crush bones. Fossil evidence shows that Leviathan and Megalodon lived in the same areas, possibly competing for the same food. These ocean giants would have been strong competitors, influencing ocean environments with their size and hunting habits. Leviathan was successful as a top predator, primarily because the Miocene waters were full of nutrients. Ocean currents brought a lot of food to feed the large groups of marine animals, and therefore other prey. However, like Megalodon, it became a problem when the Pliocene came because all the oceans cooled, and these numbers of prey dwindled. Environmental changes associated with changing ecosystems led to its extinction, and the time would come to an end while these great predators ruled their kingdom. The Paleocene Epoch, early mammalian evolution. As the Earth slowly healed from the impact of the asteroid, a new era began, the time when mammals started to dominate the land. Many species rose during the Paleogene and Neogene epochs and later evolved into the many types of mammals we know today. Now that the giant dinosaurs were gone, there was space for mammals to move into new habitats, sparking major changes in evolution. The first time the Earth began recovering from that mass extinction event was the Paleocene Epoch, approximately 66 to 56 million years ago. This was a very warm period with many dense forests, providing plenty of resources for new mammal species. By this time, mammals were very small and nocturnal. They were living alongside the larger reptiles that used to dominate the Earth. Pantolambda is one of the most notable early mammals of this era. This herbivorous mammal from North America had a strong body, a long tail, and good digging legs. Fossil findings show that Pantolambda had powerful front legs, likely used to dig out roots and tubers, allowing it to eat various foods. Its skeleton shows features from early and later mammals, illustrating how they evolved. Its ability to consume diverse food items in different environments highlights how mammals quickly adapted to the niches left by dinosaurs. Among the important groups of the Paleocene are the Cimolesta, a diverse set of early mammals that had sometimes demonstrated varied adaptations. Fossils of Cimolesta, found mostly in North America and Asia, show differences in teeth and limb shapes, suggesting they had different ways of feeding and living. Some Cimolesta species developed special teeth for insects, while others changed to eat plants, indicating they lived in many different environments. The ability to adapt and change shows how early mammals competed and seized new opportunities during the Paleocene. Purgatorius is one of the earliest mammals that looked somewhat like a primate and provided some great clues about the origin of primates. Fossils of Purgatorius, found in North America, show that these were tree-dwelling creatures with gripping hands and feet, helping later primates develop more advanced traits. The enhanced senses of Purgatorius were early indicators of evolutionary traits that would later define today's primates. The Eocene Epoch. The Eocene Epoch lasted from 56 to 33.9 million years ago, following the Paleocene. This was when many different kinds of mammals roamed the Earth. A warmer climate and giant tropical forests helped mammals adapt to their environments, and new traits developed that helped them thrive where they lived. This time has often been called the Golden Age of mammals because of the immense variety and number of living things that grew during this period. Ambulocetus, called the walking whale, shows the amazing change from living on land to living in water. Fossils of Ambulocetus show it lived both in water and on land. Its limbs could hold its weight on land, and its tail was built for swimming. Its skull and teeth suggest it was a carnivore, likely hunting fish and marine animals. This indicates that Ambulocetus connected land mammals to whales, showing the gradual changes that led to modern whales. Hyracotherium, or Eohippus, is the earliest horse ancestor on Earth. The animal was dug up in North America as a small mammal-like dog with a flexible spinal column and several toes, 4 in front and 3 in the back. An impression of fossilized Hyracotherium footprints indicates that it was a fast runner, living in soft, leafy forests, eating soft, moist plants. For millions of years, changes in the environment, like climate change and the growth of grasslands, made Hyracotherium evolve into larger animals with one hoof, like equus. These changes helped them live better in open areas and escape predators more easily. In the Eocene, there arose a meat-eating animal that evolved quite early, but was nevertheless very agile and well-equipped for hunting, called Machaeroides. Fossils of Machaeroides, discovered in North America and Europe, prove that it had a smooth body, retractable claws, and strong muscles in its limbs. In other words, it was built for fast chases and active hunting. Therefore, Machaeroides was an apex predator in its environment, probably hunting smaller mammals and competing with other large meat-eaters for food. Its evolutionary success underlies those dynamic predator-prey relations that shaped mammalian diversification during the Eocene. Titanotheres were an important group of Eocene mammals. Titanotheres, large plant eaters resembling modern rhinoceroses, had distinctive features such as flat skulls and horns used for protection and competition. Their strong jaws and special teeth helped them eat tough plants, making them the main plant eaters in their habitats. This species shows the complexity of skull and head shapes due to the different types of horns and those without. Continuity and evolutionary links. The way these early mammals evolved together helped create today's diverse ecosystems. Pantolambda, Semolester, Purgatorius, Ambulocetus, Hyracotherium, Machaeroides, and Titanotheres developed different ways of adapting, which shows how strong and adaptable mammals are when environments change. The special changes that each group provided helped create the varied ecosystems that formed during the Paleogene and Neogene periods, setting the stage for the many kinds of mammals that would rule the Earth in the millions of years ahead. From fossil discoveries and current research, scientists continue to unravel the complex evolution that these early mammals experienced, from the towering elephants and swift horses to the intelligent primates and agile carnivores. Their legacy is evident in the vast variety of mammals. The rise of mammals and the evolution of modern ecosystems underscore the profound impact of adaptation and natural selection in shaping the living world. The Miocene Epoch. The Miocene Epoch, which lasted from 23 to 5.3 million years ago, represented a key period in mammalian evolution. At this point, most of the significant groups that make up the fauna of today had already evolved. Grasslands covered the entire planet with cooler temperatures than those experienced in the Eocene Epoch, which presented new challenges and opportunities for herbivorous animals. Many of the most famous mammals in Earth's history came during these times. By now, the early primates had spread out more. This was when the first apes appeared, much larger than their ancestors. These early apes, for example, were like proconsul. They were tree-dwelling and showed tools and social behavior. Although they are not direct ancestors of modern humans, their line will be a source for both humans and other great apes. At the same time, elephants started to evolve in Africa. The early elephants, like Gomphotherium, were much smaller than the big elephants we see today, and had more than one tusk and a trunk. However, these animals slowly changed into the huge mammals we know today. Some of their close relatives, like mastodons, lived in North America, Europe, and Asia, and adapted to colder weather with thick fur and big teeth that were good for grinding hard plants. Saber-toothed cats, fierce predators, first appeared during the Miocene, around 10 million to 2.5 million years ago. With their long, sharp teeth and muscular body, these cats could easily catch huge animals like bison, camels, and mammoths by surprise and in an easy move. The Smilodon is one great hunter, and it still, up to today, has remained one of the greatest mysteries of ancient life. Other large predators, including short-faced bears and Glyptodon, the large armored animal with a similarity to modern armadillos, lived on Earth during the Miocene and Pliocene times. These animals played their role as top predators and plant eaters as the ecosystem was diverse and competitive. The Ice Ages and the Megafauna. The climate was much colder when the Earth entered the Pleistocene Epoch, which lasted from about 2.6 million to 11,700 years ago. This marked the beginning of a series of ice periods called the Ice Ages. It was a time when glaciers covered much of North America, Europe, and Asia, changing the landscape and making it cold and harsh. Such drastic changes affected Earth's ecosystems, leading to the evolutionary growth of large animals that people refer to as megafauna. These creatures are designed to survive in extreme cold. Most weigh over 100 pounds or 45 kilograms. Most of them thrived well in the cold, open areas and thick forests during the Ice Age. The most famous of these megafauna was the woolly mammoth. These were massive animals, similar to modern elephants, and well adapted to cold climates. They were long and shaggy with fur, big and fat layers that insulated them from freezing temperatures. Their long curved tusks could reach up to 15 feet or 4.5 meters in length. Their tusks were essential to dig through the snow in search of food, which included grasses, shrubs, and woody plants. The fossilized remains show that the woolly mammoths were social animals in close groups, usually headed by the oldest females. Such groups helped the mammoths survive the cold winter by working together for food and shelter. Nonetheless, the woolly mammoths could still go extinct despite their huge size and highly specialized adaptations. They went extinct about 4,000 years ago, during a mix of hunting by humans and climate changes brought by the end of the Ice Age. In addition to woolly mammoths, another notable megafauna from this period is the mastodon, Mammoth americanum. These animals were also large hairy creatures living in the cold grasslands and forests of North America. Their body shape differed from that of the woolly mammoth, having shorter trunks and legs and being stockier. Mastodons, such as Mammoth americanum, were more robust than mammoths, with shorter trunks and legs. Fossils showed that these creatures were herbivores, eating shrubs and small trees. Mastodons eventually went extinct, likely due to a combination of hunting pressure from early humans and a rapidly changing climate. Another large Ice Age creature that we know is the giant ground sloth, Megatherium. These slow-moving herbivores were enormous, weighing as much as an elephant and measuring over 20 feet or 6 meters long from head to tail. They used their long claws to strip leaves off trees. Despite their large size, the giant ground sloths were not fast enough to escape predators like saber-toothed tigers. Many of them also went extinct around the end of the Ice Age, about 10,000 years ago. Glyptodon is an armored animal almost the size of modern armadillos, living around the same time as the mammoths and the giant sloths. Glyptodon had thick armor and a large round shell. The creature also had a long tail covered with armor, and it lived in the cold open habitats that were characteristic of the Ice Age. Much like many other large beasts, they were not even safe from extinction, falling to a mix of human hunting and the warming of the climate. That means how fierce and flexible life on Earth has proven to be, replacing the mammals after dinosaurs became proof of mammals. Going from small nocturnal creatures in the Paleocene to the large mammals living through the Ice Ages shows mammals filling every niche offered to them, evolving into the varying species we see today. Modern ecologies with mammals leading atop every food chain have made the deepest impression on planet Earth's surroundings. Their influence will reflect through their traces upon the landscape and in history moving towards the Earth. Today, it is mammal-dominated land, from the tiniest mice to the biggest whales, but the history of the age of mammals goes much further than simply what lived on Earth millions of years ago. The mammals have shaped the modern world and the ecosystems in which they live by adapting, competing, and going through natural selection.